Alright, so we're recording. There was a backside to this, so there was more than just the four problems that I did in that previous video. Alright, so what do we have here? A submarine dives at an angle of 8 degrees while traveling a distance of 10,000 meters. If the submarine was initially at the surface, at what depth is it after the dive? So, we've got our ocean, and we have, I don't have gray. Is there a way to get more colors? Yeah. Alright. So, I don't know what a submarine would even look like to just goof around with it. So, I don't know, we'll just draw it like this with the little periscope up at the top. Alright. So initially we're at the surface and we dive down, and this dive is at an 8-degree angle with the surface. It dives at an angle of 8 degrees. It travels a distance. So this is the line that it's traveling. It's not going along the surface. It's not traveling along the surface. It's traveling as it dives. So it goes down 10,000 meters. Um, and we want to know what the depth is when it has traveled this 10,000 meters. So our sub is down here at this point. They probably don't have the periscope up when they're down at that depth. Alright. Now, normally I would draw sharks and stuff like that, but I need to try to get out of here in a little bit. Alright, so which trig ratio would use the opposite leg of the hypotenuse? That would be sine. So the sine of 8 degrees would be equal to d over 10,000. So to solve for d, we multiply both sides by 10,000. And let's give them an approximation. It doesn't tell us what to round to, so let's see, what do we have on the calculator right now? We're in degrees, we're rounding to the nearest tenth, so that seems reasonable. It's just a depth. Alright, so let's go 10,000 times the sine of 8, 1,391.7 feet. No, meters. Okay. Let's see what the next one is. An 8-foot long pole forms a 3-foot shadow. What's the angle of elevation with the sun? Alright. So we have the ground. We have some pole. Maybe it has a flag. Maybe it's the Robert Morris University flag. We've got the sun. My sun is awful close to the ground. It's awful close to the. It's off to the distance or whatever. Okay. So the if someone was here on the ground, the angle of elevation, you look out horizontally with the ground to that line of sight, tilt your head back, and this is the angle of elevation that you have to tilt your head back to see the sun. So the sun is so cool it's got to wear shade. Alright, now that height of the flagpole is 8 feet. and it forms a 3-foot shadow. Well, the shadow's on the ground. The shadow's not mysteriously hanging in the air. The shadow is here on the ground. And so what's the angle of elevation? Well, it's used. We're going to use the trig function that has the opposite leg or the adjacent leg, which is the tangent. So we have the tangent of angle theta is equal to 8 over 3. And we'll use the calculator and take the inverse tangent, because what we want is an angle measure. And we're in degrees to the nearest tenth. So the inverse tangent of 8 over 3, 69.4 degrees is the angle of elevation to the sun. And let's see. I'll stop there and then I'll do the next two on another video.